Video 46, Sampling Methods, Area 4, CHES Sub-Competencies 4.2.3. Review the learning objectives for this video. This is a topic that comes up again and again on the certification exam, so I am really glad you are here to work through it carefully. Sampling is the process of selecting a subset of individuals from a larger population for study. The way you select your sample has profound implications for what you can conclude from your data, and once you understand that connection, a lot of evaluation concepts start clicking into place. The two major categories of sampling are probability sampling and non-probability sampling. In probability sampling, every member of the population has a known, non-zero chance of being selected. This requires a complete list of all members of the population, called a sampling frame. Because selection is based on mathematical probability, the resulting sample is likely to be representative of the population, and findings can be generalized from the sample to the larger population. Probability sampling reduces selection bias and is considered the gold standard for quantitative research and large-scale surveys. In non-probability sampling, selection is based on convenience, judgment, or other non-random criteria. Not every member of the population has a known chance of being selected. This approach does not require a complete sampling frame, which makes it more practical when a complete list of the population is unavailable. However, because selection is not random, the sample may not be representative of the population, and findings cannot be generalized with the same level of confidence. Non-probability sampling is common in qualitative research, pilot studies, and exploratory research where the goal is to gain in-depth understanding rather than statistical generalizability. For your exam preparation, you must be able to classify a sampling method as either probability or non-probability and explain the implications of each choice for the study conclusions. You are going to see this distinction tested in multiple ways, so let us make sure you feel confident with it. Now let us walk through the 4 probability sampling methods you need to know for the exam. I want you to really focus on what makes each one unique because the exam loves to test whether you can tell them apart. Simple random sampling gives every member of the population an equal chance of being selected. This is the purest form of probability sampling. You can think of it as putting every person name in a hat and drawing the number you need. In practice, a random number generator or random number table is used. Simple random sampling is the gold standard, but requires a complete sampling frame and can be impractical for very large or geographically dispersed populations. Systematic sampling involves selecting every nth individual from an ordered list. For example, if you have a list of 1,000 patients and want a sample of 100, you would select every 10th patient. You start by randomly choosing a number between 1 and 10 for your starting point, and then count every 10th person from there. Systematic sampling is easier to implement than simple random sampling and produces a similar level of representativeness as long as the list does not contain a hidden pattern that aligns with the sampling interval. Stratified sampling divides the population into distinct subgroups called strata based on a relevant characteristic such as age, gender, race, or income level. Then, a random sample is drawn from each stratum. This ensures that important subgroups are adequately represented in the final sample. Stratified sampling is particularly useful when you want to make comparisons between subgroups or when some subgroups are small and might be underrepresented in a simple random sample. Cluster sampling randomly selects entire pre-existing groups, called clusters, rather than individuals. Clusters might be schools, neighborhoods, clinics, or work sites. Once clusters are selected, all individuals within those clusters are studied. Cluster sampling is practical and cost-effective when the population is large and geographically spread out. For example, rather than randomly sampling individual students from every school in a state, you might randomly select 20 schools and survey all students within those schools. You are doing great with these distinctions. The key is remembering what level each method selects at, whether it is individuals or groups, and what it requires to work. Now let us look at the 4 non-probability sampling methods. These come up frequently in health education practice, so understanding them will serve you well beyond the exam too. Convenience sampling selects participants based on ease of access. You study whoever is available and willing. For example, surveying students in your own classroom or recruiting participants from a health fair. Convenience sampling is the easiest and cheapest method, but produces the most biased samples because the people who are readily available may not represent the broader population. Despite this limitation, convenience sampling is extremely common in health education practice, particularly for pilot studies and formative evaluation. Purposive sampling, also called judgmental sampling, involves the researcher deliberately selecting participants who meet specific criteria or who have particular expertise relevant to the study. For example, a researcher studying the experiences of community health workers might purposively select workers who have at least 5 years of experience in diverse settings. Purposive sampling is common in qualitative research, where the goal is to gain deep insight from information-rich cases rather than statistical generalizability. Snowball sampling, also called chain referral sampling, is one you will definitely want to remember. It starts with a small number of participants who then recruit additional participants from their social networks. This method is particularly useful for reaching hidden or hard-to-access populations such as undocumented immigrants, people who use injection drugs, or individuals with stigmatized conditions. Snowball sampling is the method of choice when no sampling frame exists for the population of interest. However, the resulting sample is limited to the social networks of initial participants and may not represent the full population. Quota sampling sets specific targets for the number of participants from each subgroup to ensure diversity in the sample. For example, a researcher might set a quota of 50 males and 50 females for a study of nutrition behaviors. Unlike stratified sampling, quota sampling does not use random selection within the subgroups. The researcher simply recruits participants until each quota is filled. This provides some control over sample composition, but does not eliminate selection bias within subgroups. You now have a solid understanding of all 8 sampling methods. That is a real accomplishment, and this knowledge is going to pay off for you on exam day and in your professional work. Read the scenario stem aloud. Give students 30 seconds to consider options before advancing. The correct answer is B. This is cluster sampling because the researchers randomly selected entire pre-existing groups, which are schools, and then surveyed all individuals within those selected clusters. The primary advantage is practicality and cost-effectiveness. Rather than trying to randomly sample individual parents from all 300 schools, would require a complete list of all parents and would scatter the sample across every school. They concentrated their data collection efforts in 30 randomly selected schools. Option A is incorrect because the schools are not being divided into subgroups by characteristics. Option C is incorrect because the schools were randomly selected, not selected for convenience. Option D is incorrect because schools were not selected at fixed intervals from an ordered list. Summarize the key takeaways before